welcome in today's video. Today we are continuing with modeling of the previous question, which we solved by hand calculation using the method of visual work. And today I will show you how we can model the cantilever beam from the previous exercise. This type of example will be a bit special, as we have to determine the properties of the section by itself, as from one end or from one boundary we had that the moment of inertia was a bit different compared to the other one. And today this is going to serve also as a good video to learn how to model on AutoDesk Robot software and use this type of software in your daily engineering tasks. And without any further ado, let's continue to create a new model. And for this task, we are going to continue with 2D, and let's continue with that. And the first thing to be done in order for us to check the results in the end, we need to model the bars according to what was given in the task. And if we go back from the task, we can see that from point A to B, we have a member which has a moment of inertia twice as the other part, which is going to be the part BC. Let's go to the data here in the end. So A was assumed to be 5 meters, and from point A to point B, we had the distance which was 2 times A. So the first thing to be done before modeling any members is to define a new member section. And if we click here, then we are going to have different options. So I already had defined those members, but I will quickly show how to do that manually. If, for example, for this purpose or for this exercise, we just need to check the displacement and we can skip some of the properties of the sections. And now let's go to the new section. And there are different type of categories from which we can define our section. It can be a standard, parametric, tapered, but also there is this option here in the end which allows us to define the properties of the section as we please. So for example, for the properties of the section 2i, I just named it 2i. I just placed this data, or maybe it would be much more better if we go with the values of 1a. Just a second. If we double click here, then we are going to have the properties of the section. And as you can see, these values for one are this as shown here, but for the other member type, they are going to be doubled, as I showed previously. So if we need to start modeling, the first thing to be done, we can just select and start to create a simple member. And as you can see here, I already defined the section I, for example. Here we have the I section, we have the 2I section, and now we can continue to select the 2I section because the first span from 0 to 10 meters in this case is going to be with this value as shown from the task. Next we select the node and then we go at 10 meters, and now we already have our member with moment of inertia 2 times I. And if we select the member and if we go to the data, we can see that the section has these properties here, 2I. Next, let's continue to model the rest, which has a moment of inertia of I, and it was 5 meters. We select the end node of the first member, and then we choose the end value at 15. So now we already defined our beam structure, and what is next is to define the support reaction. And we have a fixed support here at point 1, and we go to the supports and we have to decide, or we have to choose the fixed support, and after we do that, we just add it here. Actually, it doesn't matter that much if you rotate this or not, but let's just go with the one which is rotated according to the drawing which was provided in the task. The next step to be done after defining the beam structure, as now the structure is stable and determinate, we need to add a load case before adding the load itself. So let's just add that load case here, and now we close. And next we go to the load definition, and if we go back from the exercise, we had the bending moment applied here at joint C, bending moment M, and the assumed value was 10 kilonewton meters. Now we go again to the software, and then we go to the nodal load, and now we need to add a bending moment of 10 kilonewtons. 10 kilonewtons indicates the direction of here, positive value. We click add, and now we select the joint of our interest, and then we have the bending moment added at this point. So the next step is to run the analysis. Okay, we are going to have this error, but for this exercise it doesn't matter that much, uh, as we need to see the result for displacement at the rotation at joint C. But if it's going to be a real case scenario, then we have to put real values for these members and be careful and pay special attention. This is just for the purpose of the exercise. Let's go to the load and remove the dead load of the structure, and then we just remove it in this way. Then we go to start and we run the analysis again, and next we go to the results to show the deformation. As we can see here, this is the deformation of the structure. Let's go and have these values here, and as you can see, we have that at joint C, the deflection or the displacement is going to be 149 millimeters, which comes to say that the hand calculations show the same value, and therefore the values obtained from the hand calculation can be used in the future. The next thing to be checked is going to be the rotation at joint C, and accordingly the software joint 3, and what we need to do is that we need to select this joint, right click, we go to tables, and then we go to the nodal displacement, and we choose table filtered current selection and hit OK. And here we can also see the rotation at joint C, which is going to be 0.024 radians, and if we compare with our hand calculation, we got the same. So this comes to show that our hand calculations are correct, and the formulas can be used in the future, and they are very good because they are parametric, and if someone needs to change some parameters, they can do it automatically and just input the values in the formula to get the desired result. So thank you very much guys, this was the video for today. I really hope you enjoyed today's video. If there is any questions, please leave them down in the comment section below. Thank you very much, see you on the next video.